Okay, hi Algebra 2 students, it's Miss Skelton here. I thought I would make just a little video kind of covering both topics from this week in case you feel confused and just to touch base with y'all and, make sure everybody's doing okay. So on Tuesday, the plan was just for you to make sure that you add the examples to your notes. A day, you actually did this right before the break. B day, we didn't get to do it. We were going to do it the day we came back from spring break. So simplifying radicals, the whole first day was just about learning that a exponent that's a fraction is actually the same as having a power and a root on a number. So the way that I like to write it, whatever the base is, so here the base would be 4. If I see a fractional exponent, the top number is actually the power it's being raised to, and the bottom number is the root that it's being applied to that number. So there doesn't just have to be square roots, there's also cube roots, fourth roots, fifth roots, any root that you want. So if I rewrite that as a radical, which radical is just a general name for any root, then I'll have the same base, and I'll show what root was being used, and then that base is raised to the power. So you might just see the power on the base itself, like under the root, or you might see the same root, but it could also be written as the whole thing is raised to that power. So whether you see the power after parentheses or if you see the power on the base under the root, that's the same thing. Oops. Okay, so the first day was just practicing rewriting between the two. So if I give you a fractional exponent, then if I rewrite it as a radical, the base is 4, the root is 3, a cube root. You can also think of like a tree root if you want to think of something silly, not necessarily mathematical. So the 3 on the bottom, like tree roots are on the bottom underground, that's the root. And then the 4 is squared, or you could write it as the cube root of 4 all squared. Either way. If I give you one that's starting as a root, then I want you to write it as a fractional exponent. So 5 is the base. The root is 3. And then if I don't see a power, that would just be implied as a 1. So the 1/3 power and the cube root are actually the same. So that was all kind of day 1. Wednesday's assignment, nothing to submit. Practice over this, and I posted the key so you could check it. So it's just like you're doing the homework that we would do in class that I don't take as a grade, just as extra practice. From there, the next day about simplifying radicals. So I just picked a few examples from the notes. Some of them are the same, some are different, and I thought I would work them out in a video. We did this back in the fall, but it's been a while. So we need to know about perfect squares. If you have the first few memorized, 1, but that one won't come up too much, 1, 4, 9, so 2 squared, 3 squared, 4 squared, 5 squared, and so on. Let's go up to about 100. 36, 7 squared, 8 squared, 9 squared, and 10 squared is 100. Okay, so what we're going to do when we simplify a radical, we're mainly going to stick to square roots for the most part. And we are going to try to think of which perfect square, what's the biggest one that goes into the number that's under the root. That way we can use its square root to help simplify. So if I think of 32, let's see, 32, I like to start looking at the biggest one, and I think of what's the biggest number that divides evenly into 32. It has to be smaller than 32, and the biggest one would be 16. Because 32 comes from 16 times 2. So I could rewrite the square root of 16 times the square root of 2. And since 16 is a perfect square, the square root of 16 is 4. I can't by the square root of 2, so it'll still be in my answer. And now I've fully simplified. On this one, there's actually another way we could do it. So maybe you were thinking about the square root of 32, and what if you thought of 8 and 4? You changed it to the square root of 8 and the square root of 4. Well, that's true. The square root of 4 is 2, so I could rewrite it as 2 square roots of 8, but then this isn't fully simplified because 8 can be broken down. So I could think of, okay, this is 2, the square root of 8 is the square root of 4 times the square root of 2, and the square root of 4 I can simplify again, so then it become 2 times 2 and still a square root of 2, which is going to be the exact same thing we just got. 2 times 2 would be 4 square roots of 2. So all that over to the side is just showing you if you don't think of the biggest perfect square, you'll still get it right. It's just going to be more work along the way. Okay, if it already has a number in front, like the next one, 4 square roots of 12, I'm going to leave it right there, but we'll break down the 12. 9 doesn't go to 12, 4 does. So I'm going to rewrite the 12 as the square root of 4 times the square root of 3. The square root of 4 is 2. And that 2 is going to multiply by the 4 that was in the front of the radical. So my final answer, I get 8 square roots of 3. Okay, the part we haven't done a lot of is talking about how does this work if I throw x's that have exponents in there. So same idea. If I think about the square root of x squared, well, we know that squared and square roots, they're inverses of each other that cancel each other out, and x squared is a perfect square. It comes from x times x. So the square root of x squared would just be x, because x times itself makes x squared. So when I'm looking at x cubed, I want to think about, okay, what's the biggest perfect square that goes into x cubed? How could I break that down? So I could think of x cubed, well, I know that I could break it into an x squared, which we know how to simplify that, but it would still leave me 1x left over. So I split that 3 into 2 and 1. And now when I take the square root of x squared, we already know that's x, and there's still 1x left in the square root. So another way to visualize it is saying that I had 3 x's, and when I take the square root, I'm finding like a pair of a perfect square. I found a pair of x's, which I took out, and I left an x behind. So that's just another way to visualize it. This is the final answer. Okay, if we look at the next one, x to the 4th, well, let's think about that. If I take the square root, there are 2 x squareds in there. X squared times x squared. So if I take the square root of x to the 4th, I'm going to be left with x squared because it comes from a pair of x squareds. What you'll really find is that we are basically able to divide our power by our understood square root, a root of 2, and that came out evenly. When it didn't come out evenly, we could look and see, okay, well, if I try to divide 2 into 3, it goes in 1 time, and it would leave 1 left over. So let's try it on a more difficult example. If it has numbers and variables, then we want to go ahead and find the square root of each separately. So the square root of 64, oh, that's actually a perfect square. So that would be 8. Okay, then I need to take the square root of x to the 6th and the square root of y to the 11th. So I want you to think about how many groups of 2 go into x to the 6th. There would be 3 groups. So this would be 8x cubed. And then if we think about it on the y's, how many groups of 2 go into y to the 11th? Well, let's split that into an even y to the 10th. And then we have still a y left over. And here I could do those 10 by 2 to get 8x cubed y to the 5th, and I would still have a square root of y left over. So I know it doesn't necessarily look more simplified than what we started with, but as you're doing the square roots, and this is what the skills check is going to be over, or not skills check, the assignment you submit on Friday, you're looking for how times could I divide 2 into that power. Here it went in 3 times, to 11 it went in 5 times, and left 1 still in the square root. Please feel free to ask questions along the way. We can also check via Zoom if you have any questions. So I'm available for office hours from 9 to 11 and 1 to 3. Feel free to email me, and we'll just go from there. I hope to see you all soon.